You didn't miss too much. We just were getting into the recap from last week. So welcome to week 3 of Introduction to C++. I want to make sure I record these for the people who aren't able to make it to class. I was just reminded, so thank you for that. So we were just covering our recap, and we were talking about errors. So we labeled some of the errors. The chat was saying semantic syntax, runtime, linker, compiler. And I asked, what is a linker error? And we said it's when the IDE tries to get something from an external library and it can't find it. So basically, yep, that's correct. And in the lab, I'll talk about that a little bit. Um, there's nothing you specifically do to fix a linker error unless you know, um, like specifically the linker error I created. In that example, there is no external variable called x. So basically, what you do is you'd comment out that line. But if you knew that the third-party file was out there, you'd either have to go find it or make the reference so that it's working and it's correct. So in this example with the lab, you can just comment out the linker error line of code, if that makes sense. Hoorah. Cool. So yes, here's our recap from last week: building, cleaning, and rebuilding. Compiler errors. So there's two types. There's syntax, which is when you're missing an actual piece of the code or a rule. So syntax is those specific rules that C++ has. And then semantic is when something doesn't make sense. So if you're trying to add A and B, A is a string and B is an int, that doesn't make sense to do that. So compiler warnings, similar to errors, they're not going to cause an error right away, but they may cause an error in the future. So if you uninitialize a variable or if you've unused a variable, a linker error is trouble linking to object files to create that exe. Runtime errors occur while the program's running, so it's exactly what it sounds like. So most of these are what they sound like, right? For an example of a runtime error, if you try to divide by 0, even if you do that on your calculator, it just kind of errors out. And then logic errors are errors or mistakes made by the programmer. So remember we had that if age is greater than 18, then basically only 19 years and older are able to vote because we need to put an equal sign so that we include the 18-year-olds, all right? Cool. So that is our recap from last week. I want you guys to go into Blackboard into week 3. So weekly learning, week 3, and there's this recap quiz at the top. It should be open. I think I set it to open at 11 o'clock, and it is due tonight. So if you're watching this, in the recording or whatever, just try to get this done before tonight. So we're doing this in class together. But if you're just watching the recording, then yeah, the password. That's a good question. Just check. You can also find the test either by clicking this link or in the assignments and tests section in the week 2 recap quiz there, right there. Test. What password? Answers. Test options. To test. There you go. I'll put it in the chat. So we can actually do this one together. The questions are all going to appear in the same order, and I want to do them, but I want to talk about them as we go, and I want you guys to answer them, and I'll click the answers as we go. All right. So you can follow along with me. You can go at your own speed. I'll start a timer. I think it's 20 minutes. So actually, the test will have a timer on itself. But yeah, if you want to get it open on your end, I'll give you guys a couple seconds there to get it ready, and then I'll wait for some thumbs up. And then we'll talk about the answers as we go through them because I think that'll be helpful for you guys. So once you're ready, yeah, just shoot me a little thumbs up like that, Raymond. Thanks. Awesome. Okay, so you're gonna hit begin, and then we're gonna put September 2 test in there. That's what it is, all lowercase, no spaces, number 2, September 2 test. And let's begin. All right, so first question, which of the following is not a valid variable name? What do you guys think? Simon says the 25% one. Why do we think that? Who agrees? Why do we think that? Numbers shouldn't be in the name. Yes. Perfect. That's great, Jillian. So you guys, it might not be in the exact same order, so it might not be A for you. For me, it's the first one. It's the 25%. Yeah. No int and var. Yeah, exactly. Yeah, so you don't want to combine numbers in your variable names, right? And we'll talk a little bit about how to name your variables today, but it sounds like you guys already know that, so that's good. Cool. So we'll go to next question. You can use the cout object to display output on the console, get input from the console, exit the console, or start the console. What do we think that one is? This one's pretty straightforward. Display output on the console. Awesome. Raymond, Bura, Jillian, you guys all got it. Perfect. Fatima, nice. Cool. You guys don't even need me to do this, but I think it's good if we all do it. So everyone's on the same page. We can talk about why. CIN object. What is the CIN object? Display output, get input, exit, vice versa. Yes. Nice. Okay. Good. Now these might just seem easy, but that's good. If it's easy, it means that you're remembering and you're basically refreshing your brain. And the way I kind of see, how learning works is if you do something, I think it's like 3 or 4 times. I don't know the exact stat, and I should because this is how I'm doing it. But if you do something 3 or 4 times, so if you like write it down, you think about it, but then you also read what you wrote, that's like 3 times, then you have such a higher chance of remembering it and then actually having that in your brain, for whatever the rest of the semester or the rest of your life if you're doing C++. So what happens when a runtime error occurs? The results of the program will be inaccurate. The program will end abnormally. None of these are correct, or the program will continue executing until you cancel out of it. End abnormally. Runtime errors tend to crash stuff. Perfect. Yep, that's correct. Cool. Yeah, so just by doing these, I know they might seem easy, but we've recapped it already in the PowerPoint. We covered it last week, and then we're doing this, and it's just going to solidify that knowledge for you. Cool. Question 5. What happens when a logic error occurs? The program will continue executing until you cancel out of it. None of these. The program will end abnormally, or the results of the program will be inaccurate. What do we think for this? The result of the program will be inaccurate. Kendall said D, which is the results of the program will be inaccurate. Why do we think that with a logic error? You'd say this depends on what error handling you have, but you'd say inaccurate. Yeah, let's assume that you don't know that you made the error as a programmer. So for example, a logic error is that if you're 18, right, to vote, but we just said if greater than 18. So let's assume that our check was just a mistake that the programmer made, like they just didn't think about the logic. Then the results of the program will be inaccurate because only 19-year-old and older will be able to vote. Yeah, exactly, Raymond. Perfect. Good. Okay. Oh, I have an error. Hopefully you guys don't have an error. Let's see. Just refresh my page here. Try to do that again. You guys should be on number 6. That is a runtime error. Perfect example right there, guys. Okay. The cout, display the output. CIN, put. What do we get? Number 5. Runtime, the program will end abnormally. Just did this one. The results of the program will be inaccurate with logic. Okay, question 6. Okay. A compiler error occurs when there's a syntax error in the C++ statement. The C++ compiler can't be located. The machine language code can't be interpreted properly, or there's a logic error in the program. C++ statement error. Okay, so we were getting 2 interesting ones here. Okay, so there's a syntax error in the C++ statement, is what Jillian said. A syntax error. Okay, that's what Fatima said. But then Simon said the machine language code can't be interpreted properly. And then Bura also. Okay, so we have We have 2 and 2 here. Oh, Kennel's also on C. All right. So why do you guys think you think it's got to be one of those two? Justify your reasoning for that one, Jillian. Why do you think it's that one versus the other one? They're pretty similar. So, where did my PowerPoint go? We have this one, right? Which is a compiler error, right? And compiler errors have two types of errors, syntax and semantic, right? So syntax error is a type of compiler error. So you said syntax will almost always get a compiler error. Machine language code not working would also keep it from compiling. Yeah, that's true. Doesn't machine code start being interpreted after being compiled, or am I forgetting? Um, yeah, so basically, it cannot run if it's not interpreted properly. So yeah, you're right there, Raymond. So basically, the machine code would already have been built. So if you hit build, remember that builds your source code into object or machine code. So it would have already been compiled. But now, let's say like if your machine code isn't actually running, then that's a different type of error. That could be, we made the machine code, but now when we run the program and then there's an error there and the machine code's not interpreted, that could be a runtime error or something, right? So it already compiled successfully if we've got the machine code. If it was the source code can't be interpreted properly, then that would be a compiler error, if that makes sense, because the compiler is what checks this kind of stuff, right? So hopefully that makes sense. Yes, you got it. You got it, Jillian. Yeah. So it would be the syntax error in the C statement, C++ statement, sorry. Getting these. Hopefully you guys are fine. Do this again one more time. To display output. You guys are going to have these memorized. Logic error, the results of the program. Good. Syntax error. Yes. Okay. Swag. Awesome. Thanks. Okay. What process below? That's funny. I just I'm not used to seeing that. Okay. Cool. What process below can be defined as compiling, linking together with external libraries, and creating an executable file? Sounds like building since it covers linking. So defined as compiling, linking together with external libraries, and creating. Yeah. So it's all of those steps together. Yeah, you got it, Jillian. Nice. All of those steps together. Rebuild is a combination of clean and build. It will clean the project and then build all the files from scratch into OBJ or object code. True or false? What do we think? True? Does anyone disagree with Jillian, or do we all think it's true? Take a look at the PowerPoint here. Building, cleaning, rebuilding. Rebuilding is a combination of building and cleaning, or cleaning and then building. Yep, yep, I agree. Good call. All right, cleaning the code runs through the code to ensure there are no errors. Is that what cleaning does? Remember, we talked about what cleaning does here. True or false? Remembering CodeLight, I showed you this Explorer tab here. And when something's built, we can see this debug folder. And then when we clean it, that debug folder disappears. Yeah, so you guys got it false. Nice, Fatima and Simon. False. Perfect. Cleaning is not checking for errors. What cleaning does is it gets rid of the OBJ files if something's already been built. So it basically just cleans it to a fresh state. Question 10. Okay, so we've got some images here. A missing closing, I spelled closing wrong, quote character in the code above is what type of error? The terminating quote character on the hello world is what type of error? Jillian says a compiler error. Does everyone agree with her? Dan says compiler, Buro says compiler. Yep. And basically it'd be a syntax error, right? So if we were to break down compiler into two types of syntax or semantic, it would be a syntax error or compiler error. Perfect. Okay. Returning a string instead of an int for the main function is an example of what type of error. So we can see here it's int main, so that we're expecting it to return an int as part of that function, but we returned the string Joe instead. And we basically got an invalid conversion from const char or character, so string, to int. So invalid conversion. Julian says compiler semantic. What else do we think? Do people agree with the semantic error on that? Yep, Simon does. Yep. So basically, yeah, semantic error is A plus B. When it doesn't make sense to add a string or an int or something like that, then yeah, compiler error, semantic error. Nice. Cool. Yeah, and we can also do deduction there. It's not a logic error. It's not a runtime error because it won't even run. So yeah, you guys got it. Nice. Okay, defining an external variable x and then receiving the following error is an example of what type of error? So we basically got undefined reference to x. So here we have external int x. So we're saying that there's an int somewhere else. And Bura knows this one. Jillian says logic, and then we've got a couple of people saying linker. So, okay, what do we think? Jillian, do you think justify your reasoning for if it's a logic or a linker? A lot of people saying linker error. So remember here, LD returned one exit status. So basically a zero exit status, return zero, means our program has no errors. So if we return one, but it's coming from LD, then that means it's a specific type of error, LD. Yeah, everyone's saying linker. So yeah, you guys got it. Nice. So it is a linker error because it's basically looking for an external file or an external variable um, because it actually will stop the project from running. If you have this code and you try running this, I don't know if I have an example of it, but it actually will. I know I won't do it now, but I'll show you after just because I think there's a timer on this test. But yeah, it is a linker error because as the linker is going to be linking all those objects together, it's going to be looking for this variable called x, and then it will say like, ah, I can't compile the program, I can't link everything together, so I can't create that exe. C++ handles it like an angry teacher. Yeah, so it will actually cause it to error out if it can't find it. Cool, so linker error. Okay, a couple more questions. File not found, divide by zero, or out of memory will all result in what type of error? This one's pretty straightforward. Well, we got a couple different. Raymond says runtime, Bura says logic, Hung says logic, Simon says runtime. Okay, so we're getting logic or runtime. So A or C for me. What do you guys think? Logic or runtime? Jillian's saying runtime since it would crash it. Okay, why the people who are saying logic? Let's hear your. Oh, Brewer's changed his answer to runtime now. When the loop doesn't break, got me like crash. Yeah, so like if you were gonna divide by zero in the middle of the program, so say like you have your code. This is a bad example. If you have your code somewhere and it says divide by zero, everything will run normally, but then as soon as it hits that line, it's impossible to divide by zero, right? You can't put anything into zero groups, then the program will be like, ah, and then just crash. If you run out of memory in the middle of your program could be running fine, and then it will just crash. And then say you're trying to read from a file, but that file doesn't exist, it'll also crash. Result is undefined. Yeah, so they have a way of handling it in the calculator so it doesn't just blow up. But basically, the program will crash if you don't handle it. So it's not if it's a logic error, basically remember logic is if you do something like this. So you want 18 years and older, but here, because you just did greater than, only 19 years and older. So logic is when you actually just have something wrong with your logic. Like if you say if 3 is equal to 2, but then that will never be equal, right? Um, so logic is more of like an error that the programmer makes, whereas a runtime error is something that's out of our control most of the time. Cool. So runtime error causes it to just crash. So now the following code to determine if a person can vote in an election, you must be 18 years or older. So I bolded the or, so 18 or older. However, if we run this code, only 19 people and older can vote because we didn't include age equal or greater than 18. So what type of error is this an example of? Deja vu. Yeah, perfect. That's a logic. Everyone's on the same page with that. Yeah, we basically just did the two back to back there. Okay, and then last one, if we have the following code, what will we see in the build output window? Because our variable favorite number is set, and then in bold I said, but not used. Okay, so we set this variable favorite number equal to 100, int favorite number equal to 100, but then we don't use it. We just did a cout hello and then return 0 and ended the program. What would we get? Jillian says a compiler warning. Great. Awesome. Yeah, compiler warning. So it's not an error, but basically if we're not going to use it, we might as well just delete those 2 lines. Cool, save and submit. It's out of 20. Hopefully you guys didn't hit the time limit, but go. And perfect score. Great work, guys. That's awesome. 17 out of 20. Yeah, it's because I had to restart mine a couple times there, but cool. All right, hopefully that helped everybody. Um, that was great. Awesome. Good to talk about that stuff, right? Because if you think one thing and then another person thinks one thing, it's nice to know, like, okay, that's why I was thinking this. Now I can adjust, and now I'll remember that's what a logic error is, or that's what a um, linker error is. Cool. So just to clarify some of that stuff. Great work, guys. Okay. So coming back to the week 3, I wanted to discuss, actually, not week 3, assignments and tests. So I know some of you guys, I was grading the lab already. I gave you guys your marks back for the lab from week 1, which was it week 1 or week 2? I gave you guys marks back for this week 2 lab, which was basically putting some output from your CPP saying your favorite number was no way, that's my favorite number too. And then basically you guys used the variable. So everybody did great on that. Awesome work. So those marks are back. And then I wanted to talk about this quickly, just so you guys don't forget. Assignment 1, which is just a smaller assignment. There'll be 5 of these. They're each 4%. They'll totally be 20% of your grade, which is the errors assignment here. I gave an introduction about like a video to talk about the instructions for this. And I know some of you guys have submitted it already. And if you have questions today, then ask. It's due, I think, tomorrow at midnight. So it's been available for just over a week now. So some of you guys are already finished, but basically you're going to unzip this file. It's going to be, it's going to look like week 2, lab 2, CPP. It's going to look like this. And all the instructions are here. And just don't forget, I'm just doing this so you guys don't forget to submit this before tomorrow. You're going to see there's these lines. You're going to explain, what the error is here. So what did I do wrong? Well, I typed IO Steam, not stream. And then you're going to fix it. And then you're going to type why that was wrong. So basically, you can also do it this way. You could do build. If I make this my active project, Explorer here, to lab, get my active project. And if I do this and I try to run it, we're going to see all our errors. Steam. Yeah, game design. Yeah, exactly. IO Steam. Um, so we'll see the first error we get, fatal error, IO Steam, no such file or directory, because we're trying to include a dependency, but there's no such dependency as IO Steam. So, if we fix that, save it, and then run it again, then you're going to get a bunch more errors. And basically, the whole lab is trying to make this file so it's actually runnable, right? So here we got 3 more errors, and you're seeing you're missing terminating quote characters. So you got to find that. You can click it, and then it will take you to the line, and then we see where the quote character. So basically, so on, so on. Fix the errors, zip the file, submit it, and then I should be able to run it with no errors on my end, no warnings or anything. Cool. Awesome. So I will just undo that. And I just wanted to make sure you guys were aware that.
Excuse me, sir.
Yep.
I did have a question regarding that. The lab. The part was like the favorite number divided. So you have already assigned the value of 10 to it. So when we go down and we divide it by 0, so that's an error. So we just have to comment it out. So what I did was I made 0 into a 10, and so the answer was coming out to be 1. So is that wrong? I don't know what's the right
Perfect.
way.
Yeah. So with programming, just like anything in programming, there's like 10 different ways to solve a solution. So I'm not looking for anything specific here. Like you could, I probably wouldn't comment this out. You could comment that out and then comment that out, and then you wouldn't get the warning at all. But yeah, I was going to say you could either divide it by 10 and then you get 10 divided by 10, which is 1, or you
Yeah.
could comment out the divide by 0 line, but then it basically would be an unused variable, so you'd get a warning. So yeah, just dividing it by a whole number that's not going to give you an illegal runtime error, and then
Yeah.
basically just typing here, what type of error is this? Which
No,
what type of error would that be? It'd be a runtime
because
error,
I
right?
got confused. The variable name was favorite number divided. So I thought maybe you have to divide the favorite number. So
Yeah, these
yeah,
are
but I
bad
got it.
variable names by me. I just made favorite
No,
number and
that's
then I
okay.
already I
That's
already
okay.
had fave number. So then
No,
I made favorite number divided by, and I also have this one. So there's a bunch of terrible variable names here. They're not really the point of the exercise. It's
now
more so trying to
we
figure
got
out what's
the
wrong. But
gist of the errors, but that's good. Thank you, sir.
yeah, no worries. Cool. Awesome. Yeah, so then you'll see whatever warnings and whatever you come across. So Bura, I know you had a question. Um, you were asking about this external int fave number, which is basically going to give you a linker error. And we don't reference, well, we do reference fave number right here. We try to output it to the console. And basically, it will never find this variable because it doesn't exist in an external file. So what you could do, there's 2 options. One would be a lot more work. Um, the option with more work would be creating that external file so that it actually does link and does create that connection and find that variable in the external file and loads it. I don't need you guys to do that. It's up to you if you want to figure out how to do it. It'd be cool. But basically, you could just comment that out, right? And then just make sure you answer that it's a linker error. And then, don't try to output a variable that doesn't exist because this doesn't exist in another file. So yeah, everything's cleared up now. You just got hesitated, got rid of it, or commented out. Yeah. No worries. Yeah, totally. Awesome. It's a good question. Sweet. All right. Yeah, just wanted to give you guys a little reminder about that. So let's go
Can you
into
hear me?
week 3. Hello?
Oh, can you hear me?
I can kind of hear you. It's a little fuzzy. I heard you for a second. I'm assuming you're typing now. That was Simon?
Yes, what about now? Can you hear?
Yeah, that's a lot better.
So I use another compiler like CMake for my CLI
Okay.
ID, and I'm not sure if you can run it with your compiler.
Oh, I see. Because well, when you downloaded the test, like the zip code from Blackboard, did you have to change anything?
Yeah, I just copy a main file to my IDE and use it with my compiler because your
Okay,
doesn't
that's
work for me.
okay. Which one doesn't work for you? Sorry.
Like I use CMake.
Yeah, but I can just do the same thing. So if you upload your zip file or whatever, or even if before you upload it, you copy it to, like, if you use CodeLite or like this G++ compiler, I can do the same thing where I copy it over. It just makes it easier for me if everyone's using the same compiler, which is why we all installed it at the beginning of the year. But I won't stop you from using, like, if you have a compiler that you like, I can just do the same thing where I copy and paste it into my IDE.
Well, I tried to install main GW, I guess, but it doesn't work for me. I don't know
Oh,
why.
it didn't work. Yeah, we had someone else had that issue. Who was it? Someone else. We were trying to figure it out, and just ended up using Visual Studio with another default compiler for them. But yeah, if it doesn't work for me, then I'll just copy the code from the main and then and paste it into like a new file here.
Yeah, awesome. Thank you.
Cool, sweet, and yeah, that's great. Cool. So I'll close the recap here. That should be good. And let's go into the weekly learning, week 3. Let's see what we've got to work with today. So we've got a couple more PowerPoints that we're going to go through. And then I've got all of these in-class assignments and labs that hopefully we can do some of them together. And then this last one, the constants lab, is going to be your homework for the week. And then these 2 PowerPoints, if we have time, I would like to get to them because there's some good content in there that will kind of reinforce what we covered today. So let's get into it and talk about preprocessor directives and our main function and naming variables, or namespaces, sorry. So you can download the PowerPoints if you want to follow along or just look at the screen. Cool. So preprocessor directive. What is a preprocessor directive? What does it do? They start with that hashtag, and we can send commands to the preprocessor. So let's talk about this a little bit. I might go into stop sharing this screen and actually want to share my other screen. Nice. There we go. You should be able to see it now, full screen. Cool. Chat go. Just in case you have questions. Awesome. All right. Does anyone know what a preprocessor is? Just to kind of see if anybody is ahead of the game. I know some of you guys with the with last week's lab, you guys are already doing like if statements and checking, you know, the input validation if the number was over 0 and under 100. So there's definitely, you know, some great motivation there shown with your guys' programming. So, I mean, I definitely think we can go a little bit faster to meet up with some of you guys who are doing all of that stuff, which is great because then we can get into some more fun stuff. So, awesome work on that. So the C++ preprocessor is basically, it's a program that processes your source code before the compiler sees it. So it basically, if you think about if your source code program has a bunch of comments in it, what it's going to do is going to strip all of those comments out because it doesn't read the comments. It doesn't mean anything to the compiler or the preprocessor. It's not debugging per se. It more so kind of like preps the file before it gets built. So it kind of, if you know like what minification is in JS, basically it's like getting rid of all that white space and making the file like the most efficient way as possible is kind of how I like to think about it. So all the comments it'll strip from your file and replace them with just a single space. And then it looks for preprocessor directives, which are basically, and then it will actually execute them. So directives are those lines in the source code that begin with a pound. So here's the example of what a directive is, like our include statement. And basically what it's going to do, like our include statement is the most common preprocessor directive. When the preprocessor sees that directive in there, so our include IO stream, it's going to replace that pound include line with the actual file that it's referring to. So basically it will recursively process that file as well. So there's a file out there somewhere being hosted called IO stream in the C++ library. And when the preprocessor goes through, it's gonna take all your comments out. It's gonna look for the directives like the pound include, and then it's going to replace that IOStream line with the actual code from that file, so it's all in one file. And then it's going to look at that IOStream file and say that IOStream file has comments in it as well. It's also going to go through there, strip the comments, and then basically make that file really efficient as well. Yeah, exactly. It wiped out your comments. No, I'll still be able to see your comments. It's just so that the compiler doesn't have to go through all that extra text, right? So by the time the compiler sees the source code, all the comments are stripped out and all the preprocessor directives have been processed and removed. So here's an example of some directives. So there's the pound if, pound else if, pound else, and some of these other ones that we won't really use as much, like the define. The define is an older one for like defining constants and stuff, but that's for like before standard C++ or before modern C++. Cool. So that's what a preprocessor directive does. Yeah, it just does it in the background. So it's just kind of neat for you guys to know, like that's what's going on with the pound include and with your comments and everything. Cool. So now talking about the main function in C++, you guys probably know this by now, but every C++ program must have exactly one main function, and it is the starting point of our program. It's the main kind of meat and potatoes of our programs where everything will happen. It always will have to return a successful program execution, which in this case, it's always going to be 0. And there are some other things you could return that are like constant strings, but they basically have the value of 0. So you always have to return 0. There's 2 versions of main. So basically there's main with no arguments here. On the left-hand side, you can see that. It's just an empty function. It doesn't pass anything. And basically there's this option on the it passes 2 arguments. So it passes the int and the actual character. So a couple things to keep in mind when you're doing your main function. It has to be written in lowercase. The return value also always has to be an integer. If the return value is not 0, then the operating system can check what value was returned and determine what error went wrong. So basically, if it's not 0, it will just return a different type of error code so we can actually understand what went wrong. And then, yeah, basically your main function will end up calling, as we get into object-oriented programming and creating more classes and files, it will end up calling our own programs that we write and our own functions and classes that we can use as different modules, and then kind of pass them into that main function, and it will just call all of our other code externally, if that makes sense. Cool. And then we covered this briefly last week, but I just wanted to give it a little slide so you guys actually understand a little bit more about namespaces. So I know, who was it that pointed out last week? Someone was saying, I think Simon. So basically, namespaces are like that std : cout. So why do we type std cout and not just cout? What is a naming conflict? So basically, if there's 2 namespaces that have the same function inside of them. So we'll talk about that. Names given to parts of code to help reduce naming conflicts. So we use namespaces to reduce naming conflicts is basically the end of the game. So if we have a third party that has defined a name that's also called cout, so I could make my own external file called like Ben whatever. And then in that, I could declare a function that literally is called cout. So what if I tried to call Ben : cout and std : cout, right? If I just did you know, cout, it wouldn't know which one I'm referring to, if I'm referring to the Ben one or the std one. So that's why we have namespaces, basically to reduce those naming conflicts. Because there's so many third-party files out there and functions made by other people, it's quite common that we can use a keyword that might have a conflict referring to, you know, 1 or more developers that named something the same thing. So we use the : to resolve which name we want to use. So here's a better example of it. We can see in red here all the std : cout, cout, and end line. They all come from the standard, that's what std stands for, C++ standard library, right? And like we said, you can do this using namespace. So that's what they're called, namespaces, std, which uses the entire std namespace. Now, there's a lot more functions that come with the std namespace on top of cout, cin, and endline. So you can see that all those stds are gone now. It's just cout, cin, endline. But there's also a ton more that come with it. And if you're not going to end up using those, you can actually just use the specific names. So if we just want to bring in stdcout, stdcin, and then we're only using what we need. So we don't have to bring in all the other names and make our program more bulky. So it is up to you. It's a lot easier to just do this, and it won't really slow down your program that much, but you can do that as an option, say if you had to bring in another specific name from another namespace. Fun fact, those little 2 colons are called the scope resolution operator. So that's how we choose the name we want. Cool. So hopefully that was good information for you there. And now, any questions about that before we move on? Just a little quick rundown of namespaces. The preprocessor directive. Just helpful stuff for you guys to know in C++, how it works. Slideshow. Cool. All right, I don't see any questions, so I will just keep on moving along. So cin and cout, we've been kind of getting more comfortable with now. Basically, we use it to insert the data into the cout stream, and we can chain it. So you can actually do this. I know I commented on a couple of your guys' lab 1 or lab 2s, where you guys had like a cout this, and then you did the end line, and then you did another cout underneath it. And I said like, hey, just so you know, you can chain it like so, and then you don't have to write 2 or 3 lines of code. You can put it all out on one line. So you can say data 1 is, and then you can append with the insertion operator the variable that you want to append onto that line. So you don't have to write, a bunch of these cout statements. You can do it all in one go. It does not automatically add line breaks. So if you did do cout without the end line here and then another cout, this would all be displayed in the console on one line. So I'll show you an example of that, but we just need to keep in mind you need to do the end line, or you can use an escape character, \n. I saw a couple of you guys use those on your labs, which is awesome. There's a bunch of these. There's \t, \n, and more that we can use to do tabs or new lines, etc. And that / is basically an escape character. We can use it, say if you wanted to type an escape character, like an actual slash in your console, you need to escape it with another slash. So you'd have to write a / just to get one slash. Cool. Same thing with cin. We can actually chain together our cins as well. So we can chain 2 pieces of data together here into the buffer stream. And basically ask the user to type in 2 numbers separated by a space, and then it will actually save those 2 numbers into the buffer stream all at once without us having to do a new line and then ask again a second time. So it will also extract the data from the cin stream based on the data type. So if we're asking for an int and a float, and then or maybe that's a bad example. If we're asking for a string and a float, the buffer stream will look through the stream and say like, okay, well, I've got this, and I've got 2 variables. One's defined as an int and one's defined as a string. I'm going to assign the string to the string value and the float to the float value. It can fail if the entered data cannot be interpreted. So it could have an undetermined value. So if you type in the wrong thing that's not expecting, you will get an error. But cool. So let's do some examples. Escape this. Show you guys some stuff with cin and cout. All right, so I've got this basic program here. You can download it from Blackboard in the in-class assignments and labs. It's number 1 here, basic IO in class. So we can do this together. But basically, I just have a bunch of commented code here. and we're going to go through it kind of one section at a time. And I'm going to use control plus the slash to uncomment lines. So if you basically select a line and then type on your keyboard control slash, it's a shortcut. Instead of having to do this up here, another way to do it is edit, comment, and then you can see there's the keyboard shortcut control slash. You can also comment block control shift D or control shift slash, which will do the whole selection. So there you go. So if I do this and if I do this, remember, we have to specify if we want a new line. This will actually print out the exact same thing because we don't have an end line here. So this will actually get appended to the end of it. Another thing, notice I'm using the namespace std here, so we don't have to type std in front of cout or in front of our end line. So if I build and run this, errors, what's my error? I am not running the active project, that's why. There we go. Active project model. Okay, now that it's my active project, I can build and run, and we should see they're actually all on the same line because I didn't specify an end line right here either, right? So that is actually our expected output. If I append my end line, if I just copy this and run it again, then we'll get 2 lines. To finish that one, build and run. And there we go, exact same output. Cool. All right. Now this little section, I'm going to comment these. So what's going to happen here? So we've got hello world end line, and then we're actually chaining our output here with this hello world and an end line. And then here we're chaining 2 strings together, and then we've got the \n. So these 3, we would expect what keybind, comment, and uncomment. So I've got it typed out right here, control and slash on your keyboard. You can also find the shortcut in edit, comment, and then comment line. Oh, you're no worries. It's kind of hidden. So these first 3 lines should all return the exact same thing, right? We've got our hello world end line, hello world end line, even though they're typed differently and they're chained. One's using an end line and one's using a \n. And then this last one, we can see I've got 1 string, but in between my words, I've got a \n, \n, and \n, which is the escape character. So that will actually make a new line, and it should say hello out there on 3 separate lines. So let's do a build and run on this. Excuse me, I had to sneeze. And here we go. So let's take a look at that. We've got our first 3 lines, hello world, hello world, hello world, and then hello out there on all new lines. So that's kind of what we expected. That's good. So we can comment that out. Yeah, I would encourage you guys to follow along if you can, if you've got 2 monitors or something. But if not, this is still good. Okay, cool. Is my text big enough for you guys, or should I zoom in? Like, can you guys see it okay on the screen, or should I blow it up a little bit? It's okay? Okay, thanks, Mila. Okay, sweet. So the next thing I want to talk about is the buffer stream and how characters are stored when you're typing in your console. So basically, they're read from your keyboard, not directly by cin. So they're stored in something called a buffer. So by default, the characters are going to be read from your keyboard, and you can change it so that it's a different input option. You could use your mouse or whatever, something on screen. But we are going to use the keyboard for now. It's the easiest. And they're stored in something called a buffer. This makes the program a lot more efficient because then it's not storing it in memory like with the cin object, and there won't be any blockage with that. And then basically the compiler is going to know that num1 right here that I've defined is an integer. So it's going to read from the buffer and process what it makes sense to be an int. And it ignores white space is another thing to keep in mind. So if I annotate this, we have our buffer, right? And it's something like this. And say we type in the number 123. It's terrible, but we type in 123, and it's going to see like num1 is an int. It's going to read this first number from my buffer. And say I have a bunch of white spaces here, and then I type in another number like 200. That looks like a 200. It's going to read this second number and store it in my other int. So this is all stored in the buffer, right? Does that make sense? So I've got three things declared here, an int, and a double. And we'll just uncomment this. So I'm asking for an integer, I'm looking for a num1, and then I'm going to output that I've entered num1, right? So let's run this. Got an error. Missing a semicolon here. Missing something else. Enter an integer. Oh, missing another semicolon. Sheesh. There we go. It's better. So I am, like I said, it ignores white spaces. So what we can do is I can type as many spaces as I want. I can tab, and you can see I'm way over here, and then I can type 123, and it will read the buffer. It will get rid of all of that white space, and then the buffer will put 123 into the num1, and it will say you entered 123. We can see all of those white spaces are gone. Cool? So comment those back out. Okay, so now let's say we enter 100 and then 100 again. Or if we get 100 and 200 on the first line, what am I saying? If we read those numbers from standard input, read the extraction operator. Oh, I see. So let's run this program. I'll show you. I'm going to enter 100 and then I'm going to enter 200. Delete the same commented. Oh. There we go. Build and run. All right, so it's asking me for a first integer. If I enter 100, and now it's going to ask me for a second integer. So it stored it in there in cin. So it's asking for a first integer. It stores my num1 into cin, or into the buffer. I put my second number, 200. It's going to store it in num2, and then it's going to output you entered num1 and num2, right? And I'm chaining that together. Oops, let me hit enter. You entered 100 and 200, as you can see. Now, let's see what happens. What happens if I type 100 and 200 on the first line at the same time before it asks me for my second one? So if I do 100 space 200, watch what happens. It says enter a second integer, and then it says you entered 100 and 200. So a little bit confusing at first. I know it might seem like, why is that happening? But basically, because there was already two entries into the buffer stream, and it's looking for num1 and then num2, it's going to come down here, print this out, and then it's going to, when cin is going to read num2, it already sees that a second number's been entered. So it's going to assign it already. So it prints this out, and then it automatically assigns this and moves to the next line because I already entered 200 on the first line here. Does that make sense? A little bit confusing at first, I know, but it kind of makes some things easy for us because we can ask for two things at once. As a programmer, we can say, enter your first and second number separated by a space. They do 100, 200, and then we can just move right on to the next thing. So we can take in multiple variables, at once, which is kind of cool. That back out. Okay, we can also chain our extraction operator, just like we chained our insertion operator. So just like we inserted multiple things onto one line, by using the insertion operator here. We can also chain our extraction operator. So if I run this, what we're going to expect to happen is I'm outputting enter two integers separated with a space, just like what I said. And then the user will type in, say, 100 space 200. And then what it will do is the cin object will see that there's two items in the buffer stream, and it will input 100 into the num1 variable, 200 into the num2 variable, and then it will move to the next line saying you entered num1 and num2. So let's run that and see if that's what happens. Oh, I've got more errors, eh? This before string constant. In C2, where's my error? Expected. You have a colon. It's from up here. Oh. Should be fine. Oh, now we got to figure out what this error is. Expected that before the string constant. Oh, I don't have this in there. There we go. All right. Yeah, thank you. Candle, build and run. There we go. Sometimes an extra set of eyes is good. Can get into it. Okay, so now we're asking for two integers separated by a space. So I can do the same thing. And remember, it ignores white spaces. So I can type a bunch of spaces. I can do 100, space, 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 200, space, 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 and hit enter. And then it says you entered 100 and 200, just like that. Cool. Awesome. Comment that out. All right. So now I also have num3 defined as a double here. Doubles are basically like a real number, so it has a decimal point. I think it's up to 7 decimal points. So I'm asking enter a double. So I'll do a double or a floating point number, and then I'll store it into num3, and then it will be able to output the double that I entered. So basically, it's going to recognize that what I've entered is a double and assign it to the num3 variable. So if we build and run, this is just showing the same kind of example, but with a double instead. So 10.5. You entered 10.5. Okay. But now I'm going to show you something a little bit tricky. If we run this and type 10 and then 12.5 as our second input, it'll run correctly. So I'm going to comment this out. I'm going to run down to here. Show you guys this one. So here we can see we're asking for an integer, and then we're asking for a double, and we're assigning the first variable in the buffer stream to the int num1 variable, and the second thing in the buffer stream to the the double num3 variable. Now, if we run this and type 10 and then 12.5 as our second input, it's going to run correctly because the first number is an int and the second number is a double. But what if we enter a float first? So we'll run it correctly the first time. And I'll show you what we can expect. So it's asking for an integer. So I'll type in 10. And now it's asking for a double. And I'll type in 12.5. It's going to say the integer was 10, the double is 12.5. Now, if I run this again, and what if I enter the double first? So it might not be what you'd expect, and I'll kind of explain it, but what if I enter 10.5, right? What it's going to do is it's going to read this 10. I'm going to annotate here. It's going to read this 10 as the int, right? And then it's going to store that in the num1 variable over here. And then it's going to move to the next thing and say, oh, I've got 0.5, and I'm going to store 0.5 in the num3. So we'll have 10 here as our int and 0.5 as our double. Does that make sense? So if I do 10.5, if I hit enter here, whoops, enter an integer, 5, whoops, I entered 105. Let me just restart that. Build and run project. And I type 10.5. It's going to say the integer is 10, the double is 0.5. So kind of you can see how it can kind of get a little bit confusing. So you have to be aware of how the buffer stream actually works and how it's going to read your input, right? Now, what if we gave it a string? What if we gave it something that it's not even expecting at all? So it's expecting an int. What if I type in my name, Ben? It's going to say the integer is 0, and then the double is 4.47 times 10 to the power of negative 317. So that's kind of weird. But basically what it's done is it's entered a fail state. Whoops. As you can see that I've written that there, but it's entered a fail state. So it's not sure what's going on. It read the B here. It said 0. It doesn't know what that is. And then the rest of it is just like, no, I'm not doing that. I was looking for a number and you gave me something that I did not understand. So that is a little bit about C in, C out. I'm going to take a 10-minute break here, guys, and give you guys some time to stretch your legs. But if you want to get started on this during the break, I'll just talk about it for a minute before we take a little coffee break here. But number 2 here, week 3 input-output lab. There's just an in-class lab here. I'll give you guys a spot to submit it. I'll create a submission thing there. But basically, if you go through it, there's 3 exercises, and we can read the instructions for each one. So the first one here, write a single output statement that says, hi, Ben, to the console. You don't need to do new line or end line, just display the text. So then we're going to come down here. You don't have to touch these variables. They're for some of the other exercises. And then, you just put your code below this line. So for exercise 1, we put it here. So we would do C out, hello, Ben. And then code exercise 2 is going to be, suppose Sally has 3 dogs. And her number of dogs is represented by variable X. So I want you guys to output, the output should read Sally has 3 dogs. So you're going to use X here as 3, and you're going to output so that it says this. And then coding exercise number 3 is going to be using cin and the extraction operator. We're going to get the user to enter their date of birth. So the variable M will represent the month, D will represent the days, and year will represent the year. Assume the user will enter the date of birth in the order of month, day, year, with each value being separated by a white space. So we've got 3 ints here, int M, int D, and int Y. So I've already started a little bit on number 3 here. What is your date of birth? Enter month, day, year, year. And then you guys are going to have to use cin to grab those variables and then output it. Right, so if you want to get started on those 3, we'll do them when we get back and check on your guys' work to see how you guys did. But does that make sense before we go? Any questions about that? If you want to get started, you can get started now. If you want to wait and take a little coffee break, then that's fine too. Cool, thumbs up, anything? All right. Thumbs up. Oh, they're my thumbs up show way over here, so I never see them. Cool. All right, I'm gonna pause the recording. All right, welcome back, guys, from the break, and we'll just get into this little coding exercise here together. Again, you can download it here. Number 2, the input-output lab on Blackboard in the week 3 learning folder. You cannot run your code in CodeLight. It's not showing you a build and run option. Okay. Do you have the compiler working? It might not show you a build and run if you don't have it set as the active project. So make sure you have Hello? All right. Can you guys hear me now? Sorry about that. Sheesh, I just had some internet issues. My internet just went down, so good thing we got that fixed. But sorry, that was a little bit of a longer break than than expected. All right, welcome back, everybody. Okay. Recording is in progress. Okay, so it is still recording, I think. Okay, so you guys can see me. Great, welcome back. Okay. I will share my screen. I will. Okay. I guess the recording's going, so welcome back if you were watching this. A little bit of a disaster, but I will share my screen and let's see if anyone was able to get any of those coding challenges working in their Code Light IDE. So we've got number one here that says, "Hi Ben, how did you guys do that?" That's too funny. My internet has never gone out. Only this is the second time now in 6 months that it's gone out. So the chances that it happened during the break are pretty funny. What would I do for this one? For coding exercise number one. Excuse me, number one. We're going to display hi Ben in the console. Any ideas here? I saw someone also, Kennel, you had a question. I answered it, but I don't know if you were able to hear me before the internet went down. Did you hear my answer? Okay, sorry, Kennel. So basically, I said try making it your active project. So by double clicking your week 3 lab input output and make active so it's bold and italicized here, and you should have the build and run option. If not, then your compiler might not be set up, and you can check your settings, build settings right here to see if your compiler, these should be filled out. If these are empty, then your compiler is not actually set up properly. So let me know if your compiler looks like this. Okay, so you said cout hi Ben. Okay, let's try that. I'll type exactly what you've given me there. Okay, Mila's giving me a bit more detail here. So if I do try to build and run what you said here, Simon, and I know you're probably not giving me the exact, but I'm just kind of playing devil's advocate. We get some errors, all right? Cout was not declared in this scope, so I don't know what cout is. So what would I do? We talked about it earlier today a bit. What would I do to be able to type cout without having to type the std namespace? Mila's got it with the std and the scope initializer there with the colons. But yes, Jillian's right. So we use namespace std. All right. So now if we try to build and run, it still has some errors. And what are the errors? Basically, we're missing the insertion operator, right? So we can't just do cout and then the string. We need to do our insertion operator. So now let's see if that works. Build and run. Still some errors, okay? So we're expecting a semicolon before the string constant. So what semicolon is it talking about here? Oh, down here? Oh, that's my bad. Build and run. I was missing some more insertion operators. All right, so that should run. So it says, hi, Ben, what is your date of birth? Enter a month, date, year 160133. Press any key to continue. So there's a bit of some messy stuff going on here. I'll just comment these out for now because we're only on exercise 1. So cout, hi, Ben. And then Mila, you've got it right. So you want to also add, basically, add a space here. We want to add our end line, right? Because it won't get on its own. And then if we build and run, is exactly what we're expecting right there. Cool. Uh-oh, what, Jillian? Cool. So now coding exercise number 2. We want it to say Sally has 3 dogs. My internet is getting a bit funky. Yes, you can, Simon. You can use printf. We'll talk about that a bit more when we want to actually format our printing. You can also use print, is it print with the %d, right? We'll talk about that more in the future, but for now we're just going to stick with a simple cout. We'll also talk about the get line function too instead of the cin. But how's my internet, Jillian? Is it all right? Hopefully you guys can still stick with me here for a bit. Okay. Let me know, or someone send me an email if it does go down again, just so I don't go too long. I'll have my email open actually. Let's see if you guys tell me what's going on, but the loading circle in the yellow. All right. So we wanted to say Sally has 3 dogs, right? Now I know a couple of you guys for the Welcome back. Okay. This is going to be annoying. If it goes down one more time, I'll just hotspot off of my phone. Sorry about that, guys. Let's just share my screen again. So what was the last thing I was saying before you guys lost me? Out of my control. Well, hopefully it's okay now, but thanks for bearing with me, guys. Sorry. Sally's dogs. Okay. We were talking about Sally's dogs, and okay, so basically back. Okay. So we can hard code it, right? Sally has 3 dogs, but if she loses a client, then basically this will always stay 3 because we've typed it to be 3, unless you come back and change it to 2. But we want it to be dynamic, right? We want it to use the variable. So how would I do that? How would I use the variable here instead of typing the answer or having to type it every time? Okay, awesome, Mila. So how many dogs does Sally have? C in X. Okay, yeah, so I see you're actually asking the user. Okay, let's do that. Yeah, that's a little bit more than what this is asking for, but I like it. We're showing some initiative. So how many dogs does Sally have? Question mark, space, end it, and then we'll actually wanted to put a new line in here. So I'm going to add the end line there. I know you didn't say that, but and then C in, save it to the X variable, right? So right now X equals 3. And then we want to see out Sally has, end the quote. So you got that. And then do chain X, chain it again, space, dogs. Now the reason I put a space here and a space here is because if I don't, I'll show you what happens. It'll look a little bit messy. Oh, awesome, Jillian, you got it too. Space between the number, yeah. So if we run this, we also put, yeah, that's good. So we'll build and run. So it says, hi, Ben. So that's from exercise 1. How many dogs does because you're putting it on the line, but now you can see Sally has, and then 3 dogs, and there's no spaces there. So that's why we have to put the spaces in the string before and after, right? Are you guys losing me again? A bit of lag. Okay, well, hopefully we stay together. So we put the spaces there. I guess I don't have to do the new line here, right? So that's actually what Mila said. So when you actually do it, build and run. Let me know if you lose me. How many dogs does Sally have? We enter it here, 3. Sally has 3 dogs. Cool. What about the last one here? So we want a user to enter their date of birth. The variable M represents the month, D represents the days, and Y represents the year. C in and the extraction operator is what we want to use as they enter it, and then we want to output it back. What do we want to do? I'm keeping an eye on my email just in case my stuff goes down again. All right, so I'm going to uncomment out this where I ask, what is your date of birth? Enter month, day, date, year. Have to do a new line there. And then C in, yes, awesome, guys. You guys are getting the hang of it. So we wanted to, we've got 2 orders there. So Mila said month, day, then year. Simon said day, then month, then year. Now remember, we wanted to do it in a specific order here. What was the order we wanted to do? I guess it was this one, month, day, year. So we want to make sure we save the variables in the same order that we're asking for, just to keep that in mind. So C in, M, chain it, day, year, right? And then we can append an end line on that as well. And then we're going to want to see out it. We can even see out a string with it. Your birthday is, now let's see if that works. Yeah, month, day, year is the order that we want to do. You got it, Jillian. Build, whoops, week 3. Build and run project. Let's see if this works. Oh, I've got an error. So no match for operator. Oh, did I do the wrong? I did the wrong order. I did the. Those are right. So it's saying no match for operator. Oops. Basic in-stream char, iStream type char, unresolved overloaded function type. So what does that mean? So we've got int, int, and we're wanting to save the input date of birth, CN, month, day, year. I've got an extra one of these somewhere. Run. Just get rid of that. Let's do that. Put our new line here. Yeah, the end L on the CN won't work. So we do our CNs and then we're gonna do our new line on the C out because you can't do an end line. That was my bad. You can't do an end line when you're trying to input something into a variable. So you can only do the end lines on the C out. So that was just a little bit of a brain fart for me. So we still got our dog one going. Sally has 3 dogs. What is your date of birth? Enter month, day, year. So let's just pick a month, January 1st. And what is it? 1999. I don't know what year you guys are born. And we'll just do that. Enter. Your birthday is day, month, year. Pressing the key to continue. So we want to do a new line there after 1999. Right, so at the end here, we could append L just to make it look awesome for the C out. Perfect. Cool. Now, what if we wanted to display the birthday like this? I'm going to do it in a comment. I want to display it like 1/01/1999 with the slashes. How do we do that? Simon kind of is onto something there. So what if we type slash here and slash here? Let's see what we get. And get rid of that space, build and run. This is going to be interesting here, right? Because let's take a look at what we actually get. Sally has 3 dogs. Enter your birthday, 1/01/1999. Okay, so we did actually get the slashes, which is interesting because sometimes you actually have to escape your slashes with these All right, I think I'm back. Can you guys hear me? Welcome back again. Oh my goodness. I'm so sorry about this, guys. This is a disaster. Um, okay. Sheesh, yeah. Well, we'll see how long this lasts for. Let me know. I'm watching my email. I'm so sorry, guys. I feel terrible about this because it's just distracting me from actually keeping a solid flow of what we're covering. Thanks. I appreciate you guys sticking with me through this, though. That is for sure. And if we can't cover everything today, I'll just do some recordings maybe later and upload them when my internet's solid. But if we lose it one more time, yeah, we'll just play it by ear and figure out what we can. So what did where did we leave off? I'm all flustered now.
Benjamin, can I ask one question? If, example,
Yes.
we will lost connection during our test or during our midterm exam, can we reconnect? Because you see how its internet works now.
Yeah, so for the for tests and stuff like that, I mean, if it does go down, you'll just have to keep in communication with me and we'll figure it out as we go kind of thing. You know what I mean? So it'll just be like a play it by ear. Hopefully that doesn't happen though. So like we'll do assume best case scenario and then if something does happen, then we'll figure it out as we go. Cool. Um, so where did we leave off? We talked about C in, C out. We finished the input output lab, correct? We're all happy with the month, day, year thing? I think. Yeah, seeing that. Let me chat open here. Share my screen. Yes, I think. Share? Can you see my screen now? Just full of technical difficulties today, hey? It's not sharing. Try code. Share, and it's not working. I will leave the meeting and rejoin. How about that? Okay. There we go. Should be able to see my screen now. Looks like it's working. Cool. Awesome. Got happy faces. Happy faces, happy people. Okay, so on Blackboard, we're going to go through this PowerPoint variables.ppt. I've just got it here. So I'll open it up for you guys and we will cover that. Awesome. Video should be working there too. Cool. So variables and constants. I would ask you, you guys probably know most stuff about variables by now, but there's just a couple little niche things with C++ that I want to keep in mind with variables. So when we declare and initialize them, there's all these different ways that we can do initialization in C++. So the first one is an uninitialized variable. So you just declare the type and then the name, int age. The second one is probably the one you're most familiar with, which is C-like initialization. So it's the one we've been using so far, int age equals 21. So you're assigning a value to it. It is initialized. The type is int, the name is age, and the value is 21. Then there's two more, and there's actually the last one that I really want to recommend that we start using is called list stylization, right? Or list initialization syntax. So the third one there with the round parentheses or the round brackets is constructor initialization. So when you pass things to a constructor, and then the last one is list initialization, which is for modern C++. C++ 11, you'll see this all the time. And there's reasons I recommend it. I'll show you later on, but it helps give us more error codes if things go wrong, or if there's any overflow errors or things like that. So it's actually better to initialize it with these parentheses, this last fourth option, rather than the C-like initialization. And you'll see why in a little bit. Again, with naming variables, we want to use best practices, so being consistent with our naming conventions. So using either camel case, so no spaces and then just capitalizing the first letter of the first word, or just using underscores and all lowercase. So just be consistent. Don't do both of those. I don't care which one you do, whichever one you prefer. Some people like the underscores because it's more readable, but some people don't like the underscores because it's harder key to type on your keyboard. So it's up to you what you prefer. I don't really have a preference. I think I started with this as my preference, the camel case or the Pascal case, and I actually now prefer this one with the underscores. Just because the extra space in there makes it a little bit nicer, but it'll change as you program and you'll get used to what you like. Avoid beginning names with underscores. So don't have the underscore at the very beginning of the variable. Using meaningful names, so not too long and not too short. So if you have like, say you have a program that determines the width of a room, don't use a variable name called width, because width can be for anything. So give it a bit more description and call it room width. That way we know what it's referring to, but it's still not too long and it's not too short. Never use variables before initializing them. So that's a pretty obvious one. And then declare the variables close to when you need them in your code. So we'll talk about global and local variables. Now, do you guys know a bit about global and local variables? I don't know what you guys have all covered in Java. This is your 4th semester, I believe, so you guys should have covered most of this stuff. If not, just recapping it so you guys know it in terms of C++. But do you guys know the difference between local and global variables? Awesome. Okay. Yeah, I thought so. So basically, a C++ program will look locally before it looks globally. So here, the first screenshot, that's a global variable because it's outside of the main function. Inside of a function, it's a local variable. So, if you have another function that's not main and it's just declared in there. And if you have it declared in both, so here we have int age 16 and int age 18 as a global, it'll use 16 first. So this will be the output 16. So that's just a quick recap there. So some data types that we use in C++, the fundamental data types that are used directly by the language. We've got characters, so string, integers, signed and unsigned, floating point, so basically decimal or floats, and then Boolean, which is a true or a false. And then we can get the size and precision of each of those elements in C++. You don't maybe have to worry about it too much in other languages, but with C++, it's very dependent on your specific machine, what memory you can specifically use for the right type of variables. So unlike other programming languages, you've got to be aware as a programmer with C++ what your machine is capable of storing in an int or a long int, and making your programs more efficient, right? Because it's more of a low-level programming language. You don't have to do the public-private protected, right? You still can do, let me think here. It's a good question. I'll have to answer that one because I don't think you can do signed and unsigned, which is basically signed is positive and negative. But like the global is maybe more of a public variable because it can be modified by any part of the program. But I don't think you have the same keyword like public-private. Like it's not like Java in that way where you have like a public method that's accessible by another class, right? It's just it depends how you declare it. But yeah, I can get back to you on that one because I'm not 100% ready. I haven't used it yet, but cool. So talking a bit more about these character types. So these are the types of variables we have. So for character types, they're used for single characters. So like letters or symbols, Unicode, anything like that. And then basically the size of storage in each one. So we have char, which is 1 byte, 8 bits. And then if you want to do longer than that, 8 bits is a lot. I think it's 256 characters. which can store most of the alphabet or whatever. But if you have a really long paragraph you need to print out, then you can use a char 16 or 32, or a wchar, which is the largest available character set. But for most purposes, a char would be enough. Integer types, so a short int can store 16 bits. So signed and unsigned, by default, everything is signed, which means it can be negative to positive values. So like negative 100,000 to positive 100,000, whereas unsigned is just 0 to positive 100,000. Yeah, ASCII or Unicode, yeah. Int, short int is 16 bits. Int is also 16 bits. A long int is 32, and a long is 64. So it depends what you're using it for. These are like either really large numbers or really small numbers, right? And you'll see on the next page what I mean by that. But basically, if you're talking about distances between planets in the solar system and it's like millions of kilometers, you want to use a long or a long, because you can't actually store certain numbers over like a certain, I don't know what is billion. We'll see when we go to the code there, but I don't know the exact number. But yeah, it depends what you're using it for. If it's just like a number of people in a classroom, then you could just use a int. For floating point, so this is what I was talking about, extremely small numbers. They're stored in the background as scientific notation, which you may remember from school, which is like times 10 to the power of. So right here. So a really small number would be times 10 to the power of negative 38, so 0.00038 times, and then 1.2, or really large numbers. So that's how many zeros are at the end of the number. So these are non-integer numbers. These are real numbers. And if we use float, it's important to know the precision. So the precision is basically the number of digits after the 0. So a float gives us 7 of those. A double is 15 decimal, and then a long double is 19. All right. And it is compiler dependent, and you need to know it will possibly differ on your machine than my machine. So if you're using a 32-bit version or a 64-bit version of your compiler, we can test to see what the actual difference is. Cool. And then the last type is a Boolean type, which is just basically to represent true or false. 0 is false, and then non-zero is true. So 1 or 2 or anything above 0. These can represent variables such as game over, key pressed, is invisible, basically anything that is true or false. Usually 8 bits because it's only storing such a small value. So list initialization versus C-like initialization. So I want to show you this. Actually, well, this is the example that I want to show you. You can type this out in your IDE if you like, but basically, say you have a variable called people on Earth, all right, and we have it as a long, okay, and we initialize it with the list initialization with the curly braces that I suggested, and then we are going to see out there are about this many people on Earth, 7.6 billion. So what happens, because that won't store in a long int, okay, because it's such a large number, it has to be a long, we'll actually get an error message saying narrowing conversion of 7600000 from long int to long int. So it's basically saying it won't fit in this type of variable. It's too small for the 32 bits. If we just try to initialize it like C-like initialization with the equals sign, then we won't even get an error message. It will compile, and then when it runs, it'll say there are about negative 9899345992 people on Earth. So it won't even give you the error message, and then you're going to be looking at your code like, what the heck? Why is that? So that's why we use the list initialization with the curly braces, because it'll actually throw an error. Okay, so that's kind of more of the helpful aspect of using list initialization. So from here on out, try to use the curly braces when you initialize. To see on Windows 10 start settings, system scroll, see. Oh, like if it's your 32-bit system, or yeah, for sure. Yep, that's a good point, Jillian. Thanks. So that's one example of why we use list initialization, and you can try it on your machine if you want to see if you get that error message with the long or the long. And then an overflow example. So here we've got 2 shorts, and one is 30,000 and one's 10,000, and we're going to multiply them here. So we have another short that's called product. So we're going to do 30,000 times 10,000, or sorry, 1,000, which would give us 300,000, I believe. And that's too big to fit in a short, right? Because of the amount of bits in the short. So we know the product will not fit. This is what happens when we run the program. So if we actually print it out and then we print out what the product is, we can see the sum of 30,000 and 1,000 is negative 15,488. And we know that's incorrect. But basically, that's because we're using the wrong type, right? We should be using an int here, at least, because it's double the bit size. Simon, did you try the 7.6 billion? Yeah, so you got 9.89934,592. Yeah, that's exactly what I have right here, 9.89934,592. Yeah, exactly. So basically, if you initialize it in C-like initialization, that's what it will print out. So we can actually try this if you guys want to see. It's actually pretty interesting. So if I just go to one of my here, doesn't matter, and we make an int and call it people on Earth, and then we use equals, and then I do 760000000. Now something cool about modern C++, this came in C++ 14, is you can add these backticks. So not that one. Got to figure out which one it is. Nope. These ticks, if you wanted to separate so that you can see if you've typed your number right, and it will actually ignore them when it prints it out. So I believe it's just that little backtick. And that's a modern C++ feature. So that won't work if you don't have, remember, in your workspace settings, nope, in your project settings, you don't have in the compiler, I have C++ 17 enabled. So if you don't have any of the modern C++ on, then that little feature won't be available to you. Now, if I try to see out the people on Earth, then let's see what happens. Let's build and run. Oops. Okay, so maybe it's not that backtick, is it? It's this one. Let's see here. Oh, I did 7 million, so it's still fine. It's 7.6 billion. So yeah, it is the single quote, not the backtick, where the tilde is. Okay, build and run. So we know that that number is much too large. So I got negative 9.89934,592. Now it's interesting, we have a warning here for the overflow conversion, which is nice. So you do get that, but you don't actually get an error. It's just a warning. So you might not even notice that when you're developing. Now, if we do it the way I'm suggesting from now on with the list initialization with the curly braces, and we try to build and run, while it's compiling, it'll actually throw an error and stop us from continuing. And then it will actually say narrowing conversion error. So that's why we want to try to use this, because it'll just catch a couple more things. All right. Awesome. That's cool. So coming back here, excuse me. Yeah, so same thing here. We know that basically the product of these two numbers won't fit, and it's going to give us a negative number. So if something doesn't make sense, just remember it may not be fitting in your variable type that you declared. So there's something interesting that we can use the size of operator, and we can actually use it to determine what the size is in bytes for your specific machine and compiler that you're on. For an int or a double or something like that. So if I come back to my compiler here, and let's just comment these lines out. And if I want to see what the size of in bytes is for an int, for example, oops, save, build and run. Let's get our compiler here. Oh, it didn't say. Out. Out. All right, build and run. So we can see it's 4 bytes right there. I can put an end line just so it's a little bit easier to read. But you can try this with anything. So you can do it with your double. You can do it with your. There we go. So we've got 4. See that? So we can do that with a. You can do that with any variable. So if I wanted to do that with people on Earth, for example, I could do size of and put people on Earth in there, and then I could do build and run, and we could figure out how many bytes. Whoops, that can store. And we can see, oh, this is throwing this error, but if I just do that for now, that's because the curly braces, they're catching it. But it will still tell us the size of it. It's an int anyways, so it'll be the same. It'll be 4 bytes, right? All right, well, I'll put that back the way it was. All right, cool. Another thing we can do is import the Preprocessor Directive of C-limits or C-float, and they're basically, it's an include files that contains the size and precision information about certain implementations in our C++. So there's 2 different include files, C-limits and C-floats, and basically it'll tell us the max value or the min value that we can store in an integer. So this is a bit more useful than knowing the size of in bytes for our machine. It'll actually tell us the maximum number you can put in an int on our specific machine. So if I come back here and instead of this, let's do cout all in caps int underscore max, right? And then end line. We have to include though, okay, at the top, include pound include and then C limits. You could also include C float, but this is an int, so it's in the C limits file. If I wanted to get my int or my float max, then I could include that file. But so let's save this. I'm going to comment at this line. And let's do build in. So we can see that the largest number and an int that I can store on my machine. I'm curious now, actually, what is your largest number? If you just run this little line of code and include the C limits, what is the largest number you guys have compared to mine? So I can fit in an int 2,147,483,647. So as soon as I type in 2,147,483,648, I have to use a long int. Cool. So I'm curious if you guys get the same number or if it's different. What do you guys get? Same number? Okay, that's cool. So we're probably both on a 64-bit machine with similar specs. Did anyone get a different number? If you did, it's kind of cool. So you can do that for everything here. Here's an example, you know, we can get size of char, and we can just, you know, do size of int, size of unsigned int, size of short, size of long, long, and we can get all of these numbers in bytes. To me, it's a little bit more interesting to actually get the min and max values. So here, if you print out all of these values defined in the C limits file, these are the minimum ints, shorts, and long values, and here's the maximum int, shorts, and longs. So you can see the long is a huge number. So if you're using kilometers between planets, you know, you'd want to use that. Whereas anything under 2 billion, and yes. Yep, awesome. Cool. Yeah, it should be almost the exact same number for min, except it will be -1 because 0 is part of the min, right? So it goes from 0 to that. So the difference in the negative to the positive side is actually the same from the 0 point. All right, cool. So now we're going to talk about constants a little bit. So now that we understand variables, naming variables, and the sizing that variables can hold, we're going to talk about constants, why we would need constants, and the purpose of them, kind of. So a constant, basically, if we have a program that needed the number of months in a year, okay, we could hard code the number 12 everywhere, but then you'd be typing that all over the place. And so a quick solve for this would be to use a variable called months in the year and then put that variable, months in the year everywhere. But a better way to even do this would be to use a constant. Basically, a constant, once it's defined at the beginning of your program, it can't be changed. So it wouldn't, if we use a constant, we won't be able to accidentally change the months in the year to 13 or something. If you accidentally have it in some math function or whatever, and there's a plus plus, and all of a sudden you're like, what the heck is happening? So their value cannot be changed once they're declared. All right, so there's a couple of types of constants here. There's literal constants, which is when you actually, set it, x equals 12, name is Frank, whatever, and it's the most obvious kind of constant. You're actually typing it. There's also character literal constants, which is what I was talking about earlier today, which is the escape codes. And basically, /n is new line, /r is return, t is tab. If you want to do a single quote, if you want to do a backslash. So you can actually include them in your string to your cout to your console. And you can see here he tabbed, here there's a new line, and then after the my friend, there was another new line. So these are helpful to keep in mind if you ever need them. And then the next type of constant is a declared constant. These are usually using the const word. So this is the way to do it in modern C++. You used const, and then you use the variable type, and then the variable name, and then the value. And here we're using the list initialization with the curly braces. And so here we have our example with the months in the year being 12. All right. You could also do it with pi or something like that. But here, pi is declared as 3.1415926. If we try to later change pi to equal 2.5, we'll get a compiler error, right? So pi is a constant. We don't ever want pi to change. So that's actually a good thing that it would throw an error for us. There is an older way to define constants using the pound define. Okay, and that is an older way to do it. That's from C++ 11 and before. We don't use that in modern C++, but you may see this if you're working on C++ or you're online and you're looking at some code for help, and you may see people declaring constants this way. Just so you guys know, that's the old way to do it. It's not done like this anymore. We use the const keyword, okay? Cool. So we're going to go to the week 3 constants folder. I have it posted on Blackboard here. So if you come to the week 3 section, it's number 3 constants_in_class.zip. So if you just download that, extract it, and import it into your CodeLite, we're going to open up the main.cpp, and we're going to write a program to match the expected output using constants. Okay, so I want you guys to head to your CodeLite IDE and get the week 3 constants open. Got my active project. I've got it right here. And we're going to read through the introduction. So I've got a carpet cleaning service. I charge $30 per room, and my sales tax rate is 6%. And I only let my estimates stay valid for 30 days. That way, if anything increases, I don't have to, lose money on something. So what we want to do is we want to prompt the user for the number of rooms they want to be cleaned by my carpet cleaning service, and then provide an estimate for them. So here's an example output right here. So the number of rooms is 2. The price per room is 30. So 30 times 2 is going to be 60. So I'm going to output the cost. I'm then going to times 60 by 6% and get the tax cost, which is $3.6, because 6% of 60 is 3.6. And then I'm going to add the tax to my cost to get my total estimate, which is $63.60. Now, don't worry about the formatting right now. We're not talking about that, but technically, if I wanted to be exactly accurate, we could format this as a decimal to 2 decimal points, but that's for another day, okay? That topic we'll cover another time. So just for now, we're going to focus on getting the problem solved. And then we're going to say this estimate's valid for 30 days, okay? So pseudocode, you guys should know about pseudocode by now. Have you guys learned about pseudocode? I'll look for some thumbs up. Yeah, you have? Okay, cool. So basically my pseudocode for this is I'm going to prompt the user to enter the number of rooms. I'm going to display the number of rooms. I'm going to display the price per room. I'm going to display the cost, which is going to be my number of rooms times the price. I'm going to display the tax, which is my number of rooms times the price per room times the tax rate. And then I'm going to display the total estimate, which is number of rooms times price per room plus number of rooms times price per room times tax rate. And we can see the brackets there so that the math makes sense, right? And then I'm going to display my expiration time. Cool. So I just have my template code right now, but let's actually do this. And we're going to try to use constants throughout our code, all right? So let's just this. Okay, so we have our example output that we can kind of use, or our pseudocode. So how do we want to get started? We want to prompt the user to enter the number of rooms. So we can just use our cout statement here right away and say, please enter the number of rooms. All right. So I'm going to just move these comments down as we go. Prompt the user to enter the number of rooms. The next thing we want to do is display the number of rooms. And display the price per room. So the number will be displayed right here as they type it. Then we want to display the price per room. So what would I do from here? I'm going to get you guys to do this with me. So we want to display the price per room. So for now, we know it's 30. So I'm just going to do this from a very basic standpoint and just hard code it. I'm also going to do using namespace, just so I don't have to type std. We talked about that. Using namespace std for this. And please enter the number of rooms. Cout. Okay, and then we want to enter a price per room is $30. Now, I know you guys probably already have the solution in your head for using the constants and stuff, but we're just going to do this, and I'm going to show you an example of why we want to use constants, okay? So now the price per room is $30, okay? Now we want to display the cost. So, oops, cost is going to be what are we going to do? The cost is going to be, we're going to need some variables here. What variables do we want to use? Price times number of room. Yes. So let's make a couple of variables. Number of rooms. Cost. So our cost is going to be tax rate. Perfect. So our cost we know is going to be 30. Okay. And we know our tax rate is going to be 6%. So I'm going to use the new type of initializing, and I'm going to make my number of rooms by default rooms 0, just so it's already initialized and has a value. Okay, cool. Yeah, we can do 0.6. That might make it easier. All right. 0.6. So it can't be an int. It should be a float, right? Cool. So we're not going to get into the const just yet. Okay. So our cost is going to be cost times number of rooms, right? Which will be 30 times, right now it's 0, but it's whatever the user's going to enter, which we need to do cin number of rooms, right? Let's end line here. Slash end there, line and line. Cool. All right, so now that we've got the costs, we want to display the tax, which we said was going to be number of rooms times price per room times tax rate. So do a cout tax. So we're going to do, basically what we want to do is number of rooms. Let's just say, for example, we're going to do 1 room times 30 okay, plus number of rooms 1 times 30 times 0.6, right? So I actually don't want to use my variables yet, just so I want to actually be able to test the math. So my cost is going to be 30, my number of rooms is going to be 1, okay? So 30 times 1, the cost is going to be $30. Tax is going to be 30 plus 3.6. I think that's right. Oh, sorry. The tax is just this. I did the total. Okay. End line. And then we're going to do the total estimate. Is going to be this plus this, right? So it's going to be 30 times 1 plus our tax. Everyone following along all right? Does that make sense? So that's our total estimate. Before this, we can do kind of a line so that it's separated. And then we want to also output this estimate is valid for 30 days. Cool. So that should be everything we're looking for. We're not using any variables yet. I mean, we are doing input number of rooms, but it doesn't really matter because we just want to see what it would look like with the actual numbers. Cool. So let's run this. Build and run project. All right. Please enter the number of rooms. Let's say it's 1. Price per room 30. Cost is 30. The tax is 18. So there's something wrong there with the tax because we know that that's way too much tax. The total estimate is 48, which is also wrong because it should not be 30 plus 18. And then this estimate is valid for 30 days, yes. So it's not 60%, it's going to be 0.06, right? We like that. So let's run it again. Let's double check our math. Let's make sure that that is what we want. So I'm going to run this. I want 1 room. So $30, 30, tax is 1.8. 30 plus 1.8 is 31.8, and this estimate is valid for 30 days. Cool. So what we can do is, let's say our price increased, okay, from $30 to $32. Actually, no, before we do that, let's use our variables now that we know everything's working. Okay, so number of rooms we can use here. So anywhere there's a 1, we can replace it with number of rooms. Because we know that that's what that variable represents. Anywhere there's a 30, we can replace the cost. So we know our cost is 30. And then anywhere there's a 0.06, we can replace with tax rate. So times the tax rate times the tax rate. Cool. So now with our variables, let's run this program again and see if it works as expected. So it should be dynamic this time. So if I type in 2 rooms, we should get double the price of before. So price per room is 30, cost is 60, tax is 3.6, 60 plus 3.6 is 63.60, and it's valid for 30 days. Awesome. Now let's say I've been doing this business for a couple years and my price increased from $30 per room to $32.50 per room. I can basically just do a Control F, looking for 30, and I can just replace, search and replace anywhere there's a 30 and change it to $32.50, right? Because I've got my variable here that's 30, and I can basically want to also replace my price per room here from 30 so that it says it in the string to being whatever I want it. So I can do search and replace, search for 30, find them all, replace with, search and find and replace. So what we want to do is find the 30 and change it to $32.50 and replace all. And just like that, I've upped my prices, right? Find all. Did that work? Search, find, replace. Maybe you can see where I'm going with this, but replace, 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 replace. Cool. So now we can see my cost is now $32.50. Now, if I run this, yeah, that's a bad way to do it. And this is going to be why we use constants, because I'll show you. Rebuild the project. So first of all, we've got an error because there's a double to an int happening because our cost now has a decimal. So we can change our cost to being a double. All right. And now we can run and build the project again. So hopefully it'll work this time. Now Simon's already onto it. Maybe you guys can see what I'm doing here that's wrong, but I want you guys to catch it. So if I do 2 rooms, look at this. Price per room, $32.50. Okay, that's what we expect. The cost is $65. Okay, that makes sense. The tax is 3.9, so our total estimate is 68.9. But now check this out. This estimate is valid for 32.50 days. So that is not what we want to do. We don't want to use the search and replace, right? In a small program, you might be able to get away with that search and replace and change your variable names or change your values. But in a big program with thousands of lines of code, you never know what issues you might cause for yourself. So if we want to increase our price from 30 to 32.50, our estimate for the days also goes up. So that's a terrible way to do it. We could get lots of errors this way. This is why we use constants. So let's just redo this. Okay, I'm going to get rid of this for being 32.50 days. And what we want to do is make our price per room or our cost a constant because we don't want that to change unless we change it here. Like it can't change after. All right, so we're going to add const double cost 32.50. Now cost, this is not a very good variable name, so we're going to just call it cost per room, and I'm going to make sure I change it everywhere because that's a better variable name. And then we're also going to make our number of rooms. We don't want to make this a const because it can change, right? We want the user to be able to enter a different number of rooms in the math, right? And we also want to make our tax rate up here a const because that could change. We don't need it to be a double, or sorry, a float, because a float is, remember, 15 decimal places, so we can just make it a double. So const double tax rate, const double cost per room, and then we can also add a const int for our estimate expiry. And we can make it equal to 30. And then that way, if we ever want to change how many days our expiry changes, we can just replace it here. So I'll actually just change this. Whoops. Estimate expiry and put it in there. So now that will plug in the 30 here. And then basically my cost per room, now that it's 32.50, I don't have to put this here. I can actually end that as well. Let me know if you're following along. So that's dynamic as well. So basically all of this is going to change every time any of my prices change up here. I only have to change it once at the top of my code, and then the rest of my code will function with the correct math, the correct way with the expected output. So if I build and run this, oh, I've got an error. What's my error? Oh, I did them the wrong way again. Classic. C out. Okay, build and run. There we go. So now all my constants are defined at the top of my code. I've increased my price to $32.50 now. My tax rate is 6%, and then my expiry on my estimates is always going to be 30 days. So our number of rooms can change because it's not a const. So I could do 3 rooms, and we can see here the price per room is $32.50. The cost is going to be $97. That makes sense because that's 32 times 3. And the tax on that is 6% of 100, which should almost be $6 because that's not quite 100. So that makes sense. Add 97 and 585, you get 103.35, and this estimate's valid for days. Perfect. Did everyone get that working? Now, let's say tax changes and the government comes in and they want to make it now 8%. Well, I just have to come in here to my program, change it once. Okay, I don't have to come down here and fiddle around with my tax rate. I can leave all of my logic the same. All of this can be untouched. I change it in one spot because that's the tax rate. So my tax has gone up. I also want to increase my price. So let's increase my price to $34 because, you know, if the government's taking more money for my services, I want to try to make a little bit more back. So I'm going to do $34. So I changed them both in one spot at the very top where my constants are defined. Now I can just rerun my project and we can see if I run 3 rooms again, the numbers should be a bit more, right? So now instead of it being $97.50, it costs you $102 to get it cleaned, and the government's taking $8 off of that. So the total is going to be $110. The estimate's still valid for 30 days, and our program still runs as expected. Awesome. Any questions about that, guys? That's why we use constants. I don't want to run too late here. I know. Okay, cool. I got a thumbs up from Simon. I had a bunch of other stuff I wanted to cover, but the internet issues kind of took away from that. So I do apologize. I can try to make some recordings if you would like, but I'm going to talk about this just right now before we leave. So your in-class assignment, which I can be available for some questions if you guys do have them, is basically what we just built together. If you didn't build it, that's okay. You can watch the recording and rebuild it. Is we're going to tweak the program that we just made a little bit. So now you're going to have 2 types of rooms that your carpet cleaning service can make. You're going to have a small room and a large room. So we can see here at the top, I'm going to just annotate as I go here. We've got $25 for the small room and $35 for the large room. So the sales tax rate will be 6% still, and the estimates will be valid for 30 days. But we're going to prompt the user twice. So we're going to prompt them for the number of small rooms and then the number of large rooms. So say they have 3 small rooms. So we're going to do 3 times 25, which is 75. And then we're going to do 1 large room, which is 1 times 35, which would be 35. So we would have 75. Oops. Trying to write as neatly as possible. 75 plus 35, which would equal 110, right? For all our rooms. So basically, you're going to print out the prices per room. So 25, 35. And then here we print out our cost, 110. We take our 6% of 110 to get a $6.6 sales tax. And then we add the 110 and the 660 to get 116.60. So it's the same idea, but you're going to have 2 sizes of rooms. All right. So here's an example output right here. Basically the same thing, 3 small rooms, 1 large room, 110, 660, and then 116.60 for the total price. So you're just going to modify the program we made today and add a little bit of functionality to it. Does that make sense? Any questions about that? You can you'll be able to submit it in the in-class assignment section. Yep, you can totally do the percent too if you want to make it the floating decimal the correct formatting. I'm not worried about that. I'm just more so worried about getting the logic working with constants. Okay, so don't just use variables, use constants where they make sense. So I'm going to be looking to make sure, just like today, that you use a const, for the things that aren't going to change. So like cost per large room or cost per small room, the tax rate, and then the estimate expiry are all going to be consts, right? The only thing that should be able to change is number of rooms, because the user could have a different number of rooms depending on who your customer is, right? If it's a hotel or if it's just a one-room house or apartment. So that should be the only thing that's not a const. Cool. And then I'll have a spot in the assignments and tests section where you can submit that code, or you'll just zip it up, same thing, and then I'll just be able to look at your source code and make sure you guys did it correctly with the consts and the variable declarations, using the list initialization, the curly braces, everything we covered today, and the using namespace std. Cool. Any other questions about that? Assuming not too many questions. For your extra reading, the chapter 2 and chapter 3 slides here are here from the textbook. So if you want to cover those, you can cover those, and you'll submit your, I don't have it up yet, but you'll submit your assessment. I'll make a folder for it. I'll call it assignment 2. Consts. All right, and inside of it, I'll make the due date for this for next week sometime. Coolio. Well, I think that brings us to about 1:50 here. I would highly recommend you guys to go through the these 2 PowerPoints. Oh, they're on the weekly learning. These from the Mirach textbook. They're very helpful and they cover a lot of good things. I'll probably go over them at the beginning of class next week. I was hoping to cover them today, but if you do want to, on your own time, read through those, there's some really great information in both of these PowerPoints. So even if you don't read through them now, just download them and make sure you guys have them on your, little USB drives for the future, because they're pretty sweet. Awesome. All right. Any other questions about anything we covered today in class? You can download the lab. So what I just assigned, number 4, I should have said this. There's a zip file of the lab. It's kind of like a starter code, basically. It's going to be like this, week 3 constants lab. And basically it just has the instructions. So basically like the pseudocode for a small room and a large room, $25, $35, and then what the expected output should be. Don't hard code these values, right? We're going to use consts and variables. So basically you can just download it and then write all your actual code here. Don't forget to comment your code and use the namespace and the correct type of list initialization. Sounds good. All good to you. Cool. All right. Well, I will end the recording here. I appreciate you guys sticking with me through the internet issues today. Great session. Good luck with the assignments and labs this week, and awesome work on the test we did today. So we'll do a recap again next week and cover another test. But yeah, take care, everyone. Enjoy your week, and yeah, I'll get my internet sorted. Awesome. Thanks, guys.